All right, boys and girls, spring break's coming up real quick here. So our third day of graphing rational functions. What we want to do first is I want you to put that in the calculator. So take a second, put x minus 1 squared over x minus 1. Now remember we got rationals, we got fractions, we got polynomials, so we need to be sure we're using all the right parentheses and all that stuff. Okay? So when you do, you're going to get this green line right here. So here's my y equals, or y5 right here. Don't mind this. We'll get to this in a second. Y to the fifth, or y5 is x minus 1 squared over x minus 1. Well, when I graph it, you should have gotten this green line right here. So the only difference between that and anything else is that at this 1 for green, I have an error. So let's talk about what that is. So when I have x minus 1 squared, that means I have 2x minus 1s over another x minus 1. Well, those cancel out. So what I get left is y equals x minus 1. Well, that's, y intercept the negative 1, slope of up 1 over 1, up 1 over 1, all that stuff. So that's just a regular line that we're used to graphing. But remember that whole y, or when x is 1, we had that error. So really what we have going on is we have an open circle at 1. So I'm going to go back in and draw that open circle. And that's because the 1 canceled out. Now remember, if I have x minus 1 equals 0, really what I have is x equals 1. And that's where we have that hole, at x equals 1. So why don't we have an asymptote? Because they canceled out. So if you want to say something about canceling, x minus 1, what happened at x equals 1? We have a hole. Alright, so anytime you have anything that cancels out, if you have x plus 3 and x plus 3 on top and bottom, those that cancel out, we'd have a hole at negative 3, or wherever that graph is at that particular place. Okay? Alright, the next thing are slant asymptotes. So before, we had three different situations. We had when we had a low number over a high number, that was y equals 0, right? Or meh, y to 0. Y equals 0. When we had the same number, as far as degree goes, talking about degrees here, it was y equals whatever the coefficient was. So in this case, 2/3. And the last one, when we had something like that, we didn't know what it was. We just said undefined. Well, now we're going to actually talk about what that is, and that's called a slant asymptote. So if you've read so far, here's what we're going to be doing, long division. So I'm going to be taking my, and I know y'all love long division so much, I'm going to be taking 2x cubed plus 7x squared minus 4. Okay, so we're doing long division here. It's frustrating, I know, and I'm sorry, but you just got to work through it step by step. So the first thing, 2 and an x. So we put 2x times that gives me 2x cubed. 2x times that gives me 4x. 2x times negative 3 gives me negative 3x. And what I forgot to do was I forgot to leave myself room for my 0x. So be sure you do that. So we got 0x and then minus 4. All right. Now we're back here. So remember, I'm subtracting everything. So 7x minus 4x, that gives me 3x, squared. And then that gives me positive 3a. That's a 6x. I'm making errors left and right here. So 6x. No, 3x. Cool. Bring down the negative 4. And then what times what makes x squared? So we got 3. So 3 times that gives me 3x squared. 3 times 2 gives me 6x. 3 times negative 3, negative 9. So now I'm subtracting. So if I do all that, those cancel out, that cancels out, and I get positive 5. So then I'm going to stop there because I have my slant asymptote. So I'm going to move all this off to the left if I can. Let's see. There we go. So 2x plus 3 is y-intercept of 3, then go up 2 over 1, up 2 over 1. Now remember, once again, this is a diagonal line that is dashed. It's invisible. It does not exist. So if you want, go ahead and erase part of it. Okay, that's our slant asymptote. Now we can't forget about the stuff we talked about before, so I'm going to set the bottom equal to 0 to get my vertical asymptotes. So I got x plus 3 and then x minus 1. So I set x equal to 0, so x equals negative 3, and x equals positive 1. Sorry, I can't read that. It's green. Weird. So x equals 1, another vertical asymptote there, and then negative 3, another vertical asymptote there. All right, we're not going to find the roots. We're going to let our calculator do that for us. Let's see what this bad boy looks like. So go ahead and put this entire thing into the calculator now. Let's take a look. That's what some of my other stuff was. That's going to be my blue line here. Now, here's my all that right there. And so we get this blue picture. So let's talk about asymptotes. So we have our vertical asymptote here. We have our other vertical asymptote here. And then we have that 2x plus 3 horizontal, or sorry, excuse me, slant asymptote right there. So everything is good. Now, using the calculator to find the zeros, that might be a little easier than doing it by hand. You can do it by hand, do the quadratic formula, factor out an x, do all that stuff. Okay, that's that one. So slant asymptotes, anytime you got a high number and a low number for the degree, you're going to have to do that. Example number 3. On top, we have difference of cubes. So that's a cubed minus b cubed. So I have x minus 2. This is following the formula that's on y'all's yellow chart, or yellow cardstock or whatever, all over x minus 2. Hopefully you see that x minus 2's cancel out. That means I'm going to have a whole at x equals 2. So I'm going to go back to my picture now on my calculator. I'm just going to graph this, and remember that I have an open circle of my x value of 2. So let's see here, that's my red one now. And you can't see it on here, but I'll have an open circle at 2 comma, and then if I go to my table, I'm going to see what that value would be, 2 comma 12. So do your best to roughly sketch this. And then at 2 comma 12, we have that open circle. Okay. Last thing, before we're done, is this part right here. It wants to know what is y doing as x approaches negative 2 from the left-hand side. So as it's getting closer and closer and closer, y is getting more and more and more, so that's positive infinity. When it's approaching from the right-hand side, so we look at our graph, what's coming? Oh, it's going down to negative infinity. And that's how you do all these. So from the left, for 3, it's going down to negative infinity. From the right, positive infinity. As x approaches infinity, our y is going to positive infinity. Terrible infinity sign. And as x approaching negative infinity, y is going to negative infinity. Okay, good luck. Have a wonderful spring break. See you next time. Bye-bye.